His name is Dr. Paul LaViolette, and he is the author of a number of books, some of which we've talked about with him before on the air. The books include Beyond the Big Bang, Earth Under Fire, which of course is available in video as well, Earth Under Fire. Anyway, Dr. LaViolette has a degree in physics from Johns Hopkins, received a PhD in systems theory from Portland State. He is a man whose views are highly sought after in certain circles, and we are very fortunate to have him with us tonight. And so without further ado, so Dr. Paul, thanks for... All right, so the last time that you were on the air, we talked quite a bit actually about the primary focus of your research, and I'll let you sort of lay it out, but it has to do with galactic core explosions, these violent explosions that occur at the center of galaxies, and your research led you to the ice samples in Antarctica. Maybe we could start there, and we could talk a little bit about the theory and about what you found in those ice core samples.
Okay. Yes, I was testing the theory. This is something I was doing for my PhD work in the early 80s. Had gotten some ice from Greenland and Antarctica, and particularly in Greenland, I found high levels of cosmic dust in the Ice Age part of the core, which was confirming my hypothesis, which was that there had been a volley of cosmic rays coming from the galactic center around that time and had pushed in cosmic dust into the solar system, caused a climatic mess, so to speak, in the solar system. It filled the area with dust, included the sun, so that the radiation reaching the Earth was coming with a different spectrum, much more reddened. You were getting light scattering. You wouldn't have seen the stars. You've got a lot more radiation actually coming to the Earth, but it wouldn't have been visible. It would have been much of it infrared. It would have created what I call the interplanetary hothouse effect. Then on top of that, it would have activated the sun and caused solar flaring almost continually, ice formation at the ice sheets, also ice melting. So there was all various aspects of this. But one of the key tests was to see if there was elevated levels of cosmic dust in the polar ice cap.
How do you tell if there's cosmic dust? Is there a particular element or something that you're looking for?
Yeah, you look, for example, for iridium or nickel, and these are at very high levels in cosmic dust, but on Earth much lower. And particularly iridium is a precious metal, about 10,000 times more abundant in cosmic material. Gold was another one, and I did find gold at fairly high level. As far as I know, I was the first to detect gold in polar ice.
Interesting. What about beryllium? Wasn't that one you were looking for, too?
No, to do that, you need a different technique of analysis. They find that with mass spectrometers. I was using neutron activation, which was where you bombard your sample in a reactor, make it radioactive, and then you measure gamma rays. From that, you're able to tell what's in it. Whereas beryllium-10, it's a radioactive isotope of beryllium that's created in the atmosphere when the atmosphere is bombarded with cosmic rays. And to separate that particular isotope from the other beryllium isotopes, you need an accelerator. So it's a totally different approach. But other people had done that work.
Okay.
So I was predicting high levels of that, but the other groups had found high levels.
So in the ice samples, you found these elevated levels of...
Well, yeah, iridium, nickel. In fact, they were in the ratios that you would, that they see in cosmic material, like comet or meteorite material, which tends to be very convincing that it was actually extraterrestrial and not contamination. It's difficult to make a case for contamination because where would all this iridium come from?
Right,
certainly not from the laboratory.
Right. In other words, there's not an obvious terrestrial source for this stuff.
Right. If anything, if the laboratory dust had contaminated the samples, it would have diluted rather than created, all this iridium.
Right. Okay.
We also found large amounts of tin in one sample, which was known to be there before, because Lonnie Thompson, glaciologist at Ohio State, had found it and was puzzled by what was this tin. It was up to like 70%, 60 or 70% of the sample was tin at one depth.
Huh.
And I worked with some people in Australia who were just beginning to measure isotopes of tin. And one of the things is if you find an isotopic anomaly in an element, this is another indication that it could be extraterrestrial. Because if these tin particles were out in space, they get bombarded with cosmic rays and it would change their isotopic ratios compared to what we have on Earth.
Okay.
And in fact, they did find a significant isotopic anomaly in this tin, which was the first time such a thing had been found.
Interesting. And they would say, and they were puzzled trying to come up with an answer for it.
Yeah. This tin, though, came from a different depth than the area I was testing. I was planning to test the period between 16,000 and 12,000 years ago, which was the end of the Ice Age. And it was also a time there where we had the worst mass extinction of animals since the time of the dinosaurs, the dying off of the mastodons and mammoths, saber-toothed tigers. So this was the period I was interested in, but my ice core work ended up testing an earlier period, so I was looking actually at an earlier superwave.
All right, well, that was the next question then, was once you take the ice core, what are the the time frames that you're looking at? So we're talking about, what did you say, 16,000 years before the present date? So what's that, 14,000 BC, something like that?
Right. The way I had gotten, there was a clue as to where to look. At the time I was doing this, I was studying ancient myths and lores, and I discovered there was a very advanced science coded in these lores.
Right, which we've talked about, yeah.
And we're talking about a space-age science. Whoever had encoded this stuff was at least as advanced as we are, or more advanced. And at the same time, I was studying astronomy because I was working on new physics theory. So I was studying things like pulsars and pulsating stars, stellar evolution, cosmology, things like this.
Right.
And having these two tracks of investigation going, one day I noticed that there was this myth. Sagittarius is shooting at the scorpion. These were part of this message that I was deciphering. And so when I laid out this arrow trajectory, as the myth talked about, it came within a few degrees of the galactic center. And then I realized that this was actually pointing, because there was an arrow there, the arrow of Sagittarius.
Right, the archer.
Was it was purposely put there to point out the galactic center. All those stars have moved since the time. This was thousands of years back when these constellations were formed. And
right. And maybe you could address that actually for a second. And
yeah, this is something that puzzled me a bit, because there's various zodiacs. These are in particular zodiacal constellations.
Right.
We have zodiac that we're familiar with, that's in Western astrology. But then the Mesopotamians actually had, I believe, something like 18 constellations along the zodiac. And then the Chinese, of course, have their constellation. But the ones that were part of this message that were designed actually as a cryptographic message, they employed certain cryptographic techniques, was the zodiac that's been handed down to us presently, that involves normal signs of Taurus, Aries, Pisces, and so on. So why it is that the others didn't, I'm not saying that all constellations out there are part of a message. It just happened that this set I had discovered was. And also it included some constellations off of the ecliptic, which would include like Sagitta, Aquila. Aquila is the eagle and is holding the arrow Sagitta in its claw, and actually a symbol on the dollar bill sort of connotes that. And then there's another constellation at the other side of the southern hemisphere called Centaurus, and Crucis, which is the cross, Southern Cross. Actually, they used to be one constellation at one time. And these